We are asked to factor the expression 8x to the sixth minus 27. This is what we call a difference of cubes. It's a difference because it has a minus in the middle. It's a difference of cubes because 27 is a perfect cube. It has a nice cube root. 8 has a nice cube root, and so does x to the sixth. And I can just about maybe keep this factorization formula in my head, but I typically look it up. You'll find it on the class formula sheet, and it tells you that when you have a difference of cubes, the factorization is first thing minus second thing times first thing squared plus first times second plus second squared. So when this factors, we're going to have a binomial and a trinomial, minus plus plus. And now we get to go through and fill in blanks here. The x in this factorization represents the cube root of the first term, which for us is 2x squared. So we get 2x squared minus y is the cube root of the second term. In this case, it's 3. So for our first term, we get 2x squared minus 3. Here we get 2x squared squared, which is not the nicest thing to write, but we'll clean it up in a moment. Then we get 2x squared times 3, first root times last root. And then we get the last root squared, which in this case is 3 squared. If we pretty that up a bit, we get 2x squared minus 3 times 4x to the fourth plus 6x squared plus 9. Does that really work? Let's see. If we expand it, we get 8x to the sixth. Then I have to distribute through here. 2x squared times 6x squared gives plus 12x to the fourth. 2x squared times 9 gives me 18x squared. Now I take the minus 3 and go through everything again. Minus 3 times 4 is minus 12x to the fourth. Minus 3 times 6x squared gives me minus 18x squared. And minus 3 times 9 is minus 27. You can see that the x to the fourth terms are going to cancel out. The x squared terms are also going to cancel out, and we're left with, lo and behold, 8x to the sixth minus 27. It works.